All right, guys, we are almost there. We are at the end, so I just want to review, especially these statistic problems, probably not all of them, but the ones I think you're going to have the most questions on. And I'll go back to the other packets so that you can watch this, you can go back, you can practice, and then you will be ready. So, this first page for statistics is a bunch of summations and a bunch of the geometric and arithmetic mean stuff. So this one, remember that always means the sum. 3 minus 2n. The only difference here is that instead of starting with a 1, we start with a 0. So if we put in a 0, and then we put in a 1, a 2, a 3, and a 4, that actually gives us 1, 2, 3, 4, 5 terms. So that actually means that n is the number 5 instead of the number 4 that we're used to, okay? So when you use your formula, you would say that n is 5. Then the difference, the last term, which would be the fourth, and the first term in this case would be 0 because you're putting in a 0. So if you put in 0, you get 3. If you put in 4, you get 3 minus 8, which is negative 5. And actually, you don't need the difference when it comes to the sum formula. So these three numbers in the sum formula are 5 over 2 times 3 minus 5 or plus negative 5. And when you put that into the calculator, that's 5 over 2 times negative 2. Those two cancel. 5 times that negative is a negative 5. Okay? All right, this, remember, two geometric means between means that you start with 2, you end with 54, and that there are two numbers in between. And since it's geometric, it means we multiply by a number. And then from here to here, we multiply by a number, and from here to here, we multiply by a number. Okay? So you would use your formula to find out what is that number, and then you multiply. And in this case, I know the answer is 6 and 18, so that means we're multiplying by 3. 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. So I know that that answer is H. So this would just be your, use this one, A1. This would be your AN or A4. You'd have n is 4 terms, 1, 2, 3, 4. So then your ratio when you solve it should be a 3. Okay, and then you just use the ratio. So I'm not going to finish that one out, but that's how you would start that one. All right, so for these over here, this one's pretty easy. Since you want the fourth term, you put a 4 in there. 2 to the 4 minus 1 is just 2 to the third. So 2 to the third is 8. Be careful, don't fall for the trick answer of 6. So 2 to the third is 8. And this one, like I said, I know is this one. And then this would set up the exact same as that, except instead of finding R, you would be finding D. So begins with 3, ends with 24, and then there are 2 blanks in between. So A1 would be 3, A4 would be 24, the N would be 4, and then you would just find the difference. And off the top of my head, I can't remember what that is, but that's okay. I've posted the answers as well. So let's go to the next page. This TEI question is pretty tough. So what I did was I actually just found what I was multiplying by, and I just kept multiplying until I got to the 5th term, okay, or the 5th stake. So what I did was I just said, okay, I'm starting at 24. I'm going down to 18, I'm going down to 13.5. And then it asks for the 5th term, so that means I need 2 more blanks, all right? Well, 24 down to 18 and 18 down to 13.5, that's not arithmetic because it's not the same number. So that means I'm multiplying by something, okay? But unfortunately, I'm not multiplying by well, since it's going down, you're actually dividing, so you're multiplying by a fraction. So, but unfortunately, it's not an easy fraction, like a half, because if you were to take a half of 24, that would give you 12. And then 12 would give you 6, and that would be really easy. So that means it's smaller than 1, but it's bigger than a half. So I just played around with my fractions until I got 3/4, or 0.75. So I'm multiplying by 0.75 and I get this. Then I'm multiplying by 0.75 because that's 3/4 and I got this. So then 13.5 times 0.75 is 10.125. Yeah, that's what I got. And then 10.125 times 0.75 is a long decimal, so I rounded it to 5/9. And on your SOL test, they'll tell you how many decimal places to put. So that's what I rounded to. Okay, remember, this means the sum. It's from 1 to 6, so that's not too hard. This, whenever you have a power, guys, remember that is geometric. So you would use the geometric formula sum formula to find this answer, okay? The first term would be a 2, because when you put a 1 in there, you would get a 2. And then the ratio would also be a 2, because the ratio is always whatever has the power. So since the 2 has the power of n, it's the 2 that's the ratio. So the first term plus the ratio are both 2. And then you would just use 6 to represent your n. All right, this one's pretty easy. Take the n out, put a 9 in. 1 plus 1/9 is 1 1/9. In your calculator, you get 1.1 repeating. And then when you do math, enter, it's 10/9. Or multiply that, add that, and you get 10/9. Okay, but you guys are pretty fine with that one. So then, now we have got the different types of functions. All right, a lot of this is in your calculator, so it would be hard to practice. I mean, you've got graphing calculator options on the internet, but just remember to use stat for a lot of this. Okay, the 2 points for this one would be time is almost always your x, and well, years is also time, but this year's is what we're doing. This is how many years have gone by. So your input of 1940, your output is 62.9, and then the other point would be 1980, and an output of 73.7. So if you put those into that stat, into L1 and L2, then it says linear relation, so you would choose number 4, which is the linear regression. So that's what you would do when it comes to using your calculator. And then remember, after you get that equation, you would plug in 2000. There it is right there. You would plug in 2000 because that is the next year. And you would plug it in for x because our years are x. So you would put this in for the x into the equation that you get. Most people were fine with this, okay? This is nice. It says quadratic model. So you would use quad, which I think is number 5. But what happens when you use quadratic here is you actually get a really, really small number. So for example, here's the calculator. So when I put it in, when I put these 3 points in, let me go to stat, let me edit my lists. So -1, 0, and 1, excuse me, and clear that. I want that to be 2. All right, my y values are 2, 1, and 5. All right, the problem said it's quadratic, so when I go back to stat and I go over to calculate, I want to choose quadratic, which is number 5. And when I do that, it gives me this. Well, this number is such a small decimal because it's times 10 to the -13. So you would move that decimal place over 13 times. So that's a super, super tiny number that really they're not including it. So they're saying, because this is so close to 0, let's put in 0. So that means that it's y equals 1x squared, and then this is plus 1. So there's no b. So that's why it would be x squared plus 1. All right, let's see. So this, we just ask ourselves, well, what's happening? This is going up steady. What's happening here? It's increasing slowly, and then it gets large at the end, so that's exponential. There's a lot of exponential stuff on this review, I noticed. Let's see. is nice. They're only linear options. So you just put linear, after you put these in, you just put linear in and it'll have to match up with one of those. This one has got two options. It's either linear or exponential. Linear has just a regular x. Exponential has it up in the exponent. Oh, and there's quadratic. So you would have to decide, using number 3 above, what is your best model? Well, since we decided this is exponential, then we automatically know that it's going to be one of those two. And then when you go back into the calculator, choose exponential, it'll clarify which one's A, which is the first one, and which one's B. Most of you guys didn't have questions about these. So let's look at variation. And I do think some people had some questions on this. What I would clarify at the beginning is that this is the formula you use to find the constant, but the formula we used a lot in class was k times x. So direct variation meant that we multiply whenever we set up the formula. And then inverse variation meant k divided by x, so that meant that we divide. So it probably just depends on how your teacher approached it, but that's how we talked about it in class. So these are the two common formulas that we use more and more often. And then joint meant that we did both. Meant that we multiplied by many things. So instead of just k times x, a lot of times another term, another variable came in as z. So that's the setups that we used when we were translating these problems. So that's kind of what I want you to think of as you're reading these problems. So the time it takes to travel a given distance varies inversely. So the time, so that's a t, varies inversely, which means the constant is going to divide. And what does it divide by? It divides by the average rate of travel. So I'm going to use R for rate. And I was telling a student that was working on this, instead of using x and y all the time, I just use the variables in the problem because then it's easier to substitute in. So it says averaging 42 miles an hour, so that's the rate. So I'm going to put 42 right here. And then for 5 hours, I get a 5 right there. All right. Then it asks another question. Well, these are the two numbers I'm going to use first to find my constant. So when I multiply that over, I get 210. That's my constant. That's not the answer, but it will give me the formula for the rest of the problem. So right now, it's t equals, instead of the k, we now know its number. 210 over r. So now we can answer the second part of the question. It took him 4 hours and 20 minutes. So that is the time. So 4 hours and 20 minutes, 20 minutes out of 60 minutes is actually a third. So I'm going to use 4.33 because that is the decimal form of 20 out of 60. Then that equals 210 over r. And if I want to solve for r, I'm just going to cross multiply. Make that a fraction. I get 4.33r equals, go this way, 210. When I divide both sides by 210, I get, I just don't have my calculator on me. I must get around 48.5 because that's the one I circled. So that is the rate on average that he's going. So that's how you set that up. So when you do something like this, the volume, so I'd start with V, of a sphere varies directly, so that means you're multiplying with the constant, with the cube of the radius, so don't forget that it should be cubed. So the volume varies directly, so I'm going to multiply by the cube of the radius, r cubed. If k is the constant, which is the formula? So volume equals k times r cubed. So that's why we would choose that one. All right. So there are a couple of other problems that are similar to this. I'm probably not going to go over all of them because they are very repetitive and I want to make sure to get to some of the other types of statistics. So let's see, Hooke's law. All right, I think This one's inverse. This one's varies directly. So since this one's direct variation, it's a lot like the ones I've already talked about. So use what we did on the other page to try this one on your own. You've got to go back and plug the numbers in. Okay, but this one is inverse variation. So the formula is going to set up a little bit different. The volume of gas at a constant temperature, so again, that's V equals, is inversely proportional. So that means I divide it by the pressure, and I'm going to say P for pressure. That makes it easier for me to substitute. If a certain gas occupies 9.84 liters, so that's the volume, 9.84 equals the constant over pressure of 50, okay, what is the approximate, blah, 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 so I'm going to answer that in a second. I first have to use these two values to find the constant. So I cross multiply, and K equals 492. Now that 492 helps me know my formula. So I'm going to put it in here, so that's the volume equals 492 divided by the pressure. Now I can answer the question. What is the approximate pressure when the volume is increased to 12 liters? So I'm going to put this in for volume. So 12 equals 492 divided by P. Again, I'm going to make it a fraction, cross multiply. 12P equals 492. Divide both sides by 12, and I get 41. And so that's why it's 41 centimeters, okay? So regardless of the formula, you normally have to use the first pieces of information to get the constant, then you use the formula with the constant to actually answer the question that's being asked. All right, let's see. That should, I think, be enough to answer your questions for direct variation or inverse variation. And if it's a jointly, you would just have a couple of things being multiplied in. So I think that's good for variation. So let me start a new review for this bell curve stuff that we've done recently, so that we all can kind of regroup.